Thompson. I'm from Kaplan Thompson Architects in Portland, Maine. We are a 8-person architecture firm. We're not design build, we're design only. Morgan in the back is also a Passive House consultant, so the two of us are, and then we've been going through culture change in our business as well. We do a lot of single-family residential. We have a modular building effort we're doing with Kaiser Homes in Maine. We do some low-cost stock plans. We do a wide range of things. What I'm here to talk about today, though, is our multifamily efforts and where our multifamily work has taken us, especially in the realm of affordability. I think any of us who have been in the Passive House game for a little bit, this is the first one. And it honestly took me a little bit of time to really catch on to the fact that this is a multifamily building. Most of the buildings you see in Europe are multifamily buildings. And I think that's because there's something about the United States that a lot of construction innovation is clustered in single family. And I'm not, there's I think a lot of reasons behind it, but a lot of the sort of real innovation streams happen in single family custom homes. So the first Passive House was a single family home in the United States. Our first Passive House is a very expensive custom home built by Adam Cohen in the mountains of Virginia. And it's not a good project to talk about affordability. It was always going to be an expensive house. That was always on the table. So, but there's a huge amount of innovation. We got a big learning curve for everyone involved. And that's, I think, pretty common when I go to conferences. I see a lot of expensive single-family homes that are passive houses, and they're expensive single-family homes first. They happen to get an innovation goal grafted on them. So this is something different. This is a 9-unit building in Thompson, Maine, and it is right down by one of the big boat yards, right on the ocean. And that white building in the back was a 9-unit apartment building that burned. And we got a call from a contractor who we did a house in Rockland with, and his call was, I'm working with the owner, he's got his insurance payments from the building. Can we do a net zero buildings for his insurance payment only, whatever that money is, and we need to break ground in 4 weeks. So we wouldn't say yes to everyone, but we'd done a project with him before. So we said yes, and we had a 2% fee. Yeah, almost. So this project was interesting to us because we used a lot of the shorthands we'd done on other projects. So this is, in some ways, this is sort of like a Nessie building. This is a double stud wall cellulose building with an exterior air barrier. It's got a truss roof. It's slab on grade. There's 9 apartment buildings, 3 per floor. And they're 630 square feet, 2 bedrooms. I think they were mostly rented before they even finished construction because it was the first new apartment building built in Rockland in a while. Here's a section. It's a 60 by 36 block. The only way this fee would ever work was everything had to be simple, and we had to work with what we knew. So it's a big pile of cellulose in the roof. It's a 12-inch double stud wall. It's 4 inches of foam underneath. And these are sort of, what is the what's the Western Mass Rural Development Project? It's that same model that a lot of people built. Carter Scott, similar kind of projects to that. Here's our CAD model. The trick to this as a multifamily unit was it has one means of egress because it has these exterior walkways that go down 2 sides. So this is real affordable. There's no stair towers on this. This side faces south, which of course leads you to this funny peculiarity where you have a big giant overhang over the south-facing windows. That's the egress. And this building, these tenants, they all sort of hang out on these porches and they pull their stuff out. But we had good south-facing. It was not too far from the ocean. That's one of the main construction tricks. So it's basically, in energy-wise, they're 9 townhouses. It's not an apartment building with a central corridor. They all have egress to the outside. Yeah, here they are framing. 4 weeks later. And it's a vented truss. They plywooded the underside of the truss to get their air barrier on it. Brendan did something pretty clever, which was that he didn't put up any of the interior partitions. And this is not a certified building. So, and he floor doored the whole shell as one big lump. And he got it down below 0.6 ACH50 for that. And that made us feel pretty safe since we're doing an exterior air barrier cellulose building that people warn us could have moisture problems.
Is that before or after windows?
We did, windows were in. Yeah. It was basically a finished exterior shell except for his party walls. And we found some, we did a nice mix of sidings. It's hardy, big sheet hardy panels. We got them to paint it bright orange. We found this Empire block by Nichiha, which is these fiber cement units. Those, Richard and Arthas found those. It's a Marvin double glazed windows in the end. So here it is. This is the brand new building. It's got room for, I think, a big rack of PD across there. That should be there soon. And it was, it's a done building. So this is stretched, isn't it? This, by the way, this is our software dashboard. This is this front end that we built on the front of PHPP, just to sort of add some legibility and also to give us to not hunt through 50 tabs. I could talk about this later, but it was based on lots of things other people did. This is what the house was, the building was as built. It hit 0.6. It's an exhaust-only, bath fan ventilated building. So it does not have heat recovery. R44 walls, R81 roof, R24 slabs, Marvin double glazed integrities with the high solar heat gain package. The yellow bars are the keys. It is not a 4.75 building. It's an 18.42 building. So it's not a passive house. And the primary energy is 83 instead of 38. So a couple things. This is this $100 a square foot building. This is what this started looking like. Electric resistance heat in the apartments, bath fan ventilation, all those things, and electric hot water as well. So it's a energy intensive building as a fairly low energy heating building, I would say. And our dashboard, this is one little dial we watch, which is what percentage of the heat is coming from mechanical heating, what percentage is coming from solar gains, and what percentage is coming from people, lights, and appliances walking around the building. Here is where's the energy leaving, which is ventilation and air leaks, windows and building shell. And then this is of the shell, where is the energy leaving from, and this is a wall-dominated building, roof, and slab on grade. So those little dials, we sort of watch these. So we ran some quick numbers about what would it be to turn this building into a passive house for everyone here at this conference. And mostly, we added an HRV. We didn't even, this is probably a nice American or Canadian ERV in the unit. That was 9 of the 18 that came out of it. The walls got 2 inches thicker. The roof got an extra foot of cellulose. A little bit under the slab. It's just sort of that little incremental all the way around the edge. And you can see that now it's that classic balanced gauge of solar gains, people, lights, and appliances, and mechanical heating. It's sort of at that third pie chart. So this is not how the building was built, but we did take a look at what it would have been to get there. $20 a square foot would have probably done it. So that's the first project we're showing. The second one is a 7-unit townhouse building in downtown Portland that's under construction right now, and it's called Harborview Townhouses. This is a market rate project. We were approached by developers, some successful developers in town. It's a non-subsidized project, and it is 7 townhouses. You walk in your door and you come up inside the unit. They're about 1,800 square foot each. They wanted a really contemporary building. It's right on the water, and these are the developers have done. They did the first leased platinum home in Portland with Chris Riley. They're interesting folks because they did their lead home. They got enough of a green aura to just keep moving ahead as the green developers in town. This is our concept for the building. It's a lobster roll, which is some really expensive stuff with a bunch of cheap stuff wrapped around it. So it's a building which has the living rooms, kitchens, and all the living spaces are up a level on the second floor where you can get sun and light and views. Downstairs, are 2 bedrooms, which honestly are probably not going to be used very much because the top floor is the master bedroom, because everybody and they've sold 4 out of the 7, everybody who's buying are empty nesters, 55 plus and older. So the downstairs is their exercise room, their home office, their kid comes to stay with them, and they have a fabulous apartment in the top where they look out over the ocean. And then they're nice here. Here's the unit layout: 1, 2, 3, 4, 5, 6, 7. There's 2 in the back. They're the least expensive. The ones in the front are $450,000. The ones in the back are $350,000. The ones in the middle, we found these big roof decks. This side faces south. The harbor's here. They're building it for $140 a square foot. Here's our elevation of the south elevation. Here's a section through it. You can see that living level. And this is for our sales sheet for the condo buyers. Here's the downstairs. Double stud wall again. They decided they wanted to do this. We sort of put it out to people if they could do what they like. It's a code roof. It's a slab on grade building again. Foundation going in. Panelized, coming from Hancock lumber. I gotta move fast. I'm actually over 20 minutes time. Big windows, these huge 12-foot ceilings in the back that look back into the neighborhood of the city.